Today we're going to talk about adding and subtracting rational numbers. So before we go into those rational numbers, remember those rational numbers are fractions and decimals. We've been dealing with integers so far, which are those whole numbers that are positive and negative. So before we get into those fractions and decimals, let's talk about just those rules that we use when we're adding and subtracting positive and negative numbers. Okay, so when they both have the same sign, so when they're both positive, we've been adding numbers that are both positive for forever now. That'd be like 3 plus 3. We just add them, it's positive 6. Same thing when they are both negative, we'd add them together and keep the common sign. Common meaning that they both have that sign. So like a negative 2 plus a negative 3, add 2 plus 3 is 5, keep that negative sign. Okay, and if you think back to those chips we did, these would be 2 negative chips, 3 more negative chips. Altogether, we'd have those 5 negative chips. When they have different signs, so when one is negative and one is positive, like a negative 2 plus a positive 3, that's when we're going to have those like negatives, and then we're adding those positive chips. So some of them are going to cancel out into 0 pairs. So that canceling out of those 0 pairs is that subtraction. So we're going to subtract the numbers. So we'd subtract 3 minus 2. It's whatever the bigger absolute value is minus the smaller absolute value. So 3 is larger than 2. So we would do 3 minus 2. And we keep the sign of the, I'm going to put it in quotations because it's the larger number, but we're really just talking like larger absolute value. Okay. So since the 3 is larger than a 2, our answer would be positive since the 3 is positive. And you always think back to those chips, we'd cancel out those 0 pairs. That's that subtraction piece. And then what's left over is what there would be more of. So there'd be more positives, so it'd be positive 1. Okay. That's our adding rules. Subtracting. Remember, we didn't really learn how to do subtracting. We did with those chips where we had to take away, but if we didn't have to take away, if we had to take away negatives and we didn't have negatives to start, we'd have to like add 0 pairs. That got super confusing. So our rule is that we just change it to addition of the opposite. And I really, really, really want us to focus, especially with rational numbers, rewriting that problem. So if we have a negative 2, not plus, minus a 3, we keep the first number the same. First number stays a negative 2. Change subtraction to addition. Change a positive 3 to a negative 3. And then we just use our adding rules from above. I really want us to take the time to do that step of rewriting it as addition because it clears up so many tiny little mistakes that we usually make. Okay. All right, so let's move into our rational numbers. So we have decimals and fractions that we're going to be working with today. We're going to start with decimals. I find decimals to be a little bit easier, so we're going to start with the easier one. Okay, when we add and subtract decimals, just remember that we have to line up those decimals. What I mean is that we stack them on top of each other. So if we had just positive numbers here, to refresh how to stack them, we'd have 3 and 45 hundredths, 3.45. And right underneath where this decimal is where the decimal in 8 and 2/10 would go, 8.2. And then we'd fill in our numbers around that decimal. Any empty spaces we have, we'd fill with a 0. And then we'd add up, bring that decimal straight down. Okay. Great. So let's get into our negative and positive decimals. Always pay attention to what the symbols is in the problem. We will have some subtraction and some addition mixed in here. Here we are adding. We are adding and they have different signs. They have different signs. One is negative, one's positive, so we subtract. We look at those absolute values or the numbers without like negatives with them. We'd have 7.62 and 4.05. The larger one is 7.62, so we would put that one on the top. You can, I'm going to put that down here actually. And then we'd subtract the 4.05. This is telling us how many 0 pairs are going to cancel out. How many are going to cancel out? We are subtracting, so we cannot do 2 minus 5, so we have to borrow from that 6, make it a 5 to make the 2 into a 12. 12 minus 5 is 7. 5 minus 0 is 5. Bring our decimal straight down. 7 minus 4 is 3. We look back up to our original number. Which one of those was larger? The 7 was larger, the 7 was positive, so our answer is a positive 3.57, or 3 57/100ths. Okay, same thing here. Now we have numbers with the same sign because they're both negative. When they have the same sign, we add them and keep their common signs. So we just add our 8.5 and 13.6. When we add, the order does not matter, but to keep it the same so that we never have to question what to do, I like to always put my larger number on top. That way, no matter whether it's subtraction or addition, we're always setting up that problem the same. 6 plus 5 is 11. Bring my decimal straight down. 8 plus 3 is 11, plus 1 is 2. 8 plus 3 plus 11 is 12, sorry. Carry my 1, and then I've got 22. Go back to the problem. They were both negative numbers, so as we're adding more negatives to a negative number, it's getting even more negative. That answer should be negative. Don't get these confused with the multiply and divide rules that we have learned. Okay, it's addition. Always think about what's that problem asking. Number 3, first thing we're going to do is rewrite that problem. I'm going to do that in a different color so that it stands out for us. We've got 12.8. First number stays the same. Change that subtraction to addition. Take the opposite of 21.6. That would be a positive. Sorry, the opposite of a negative 21.6 is a positive 21.6. Here we have two positive numbers being added up. We have been doing that for a while now. Make sure we line up those decimals. They are stacked right on top of each other. Bring it straight down into our answer. We will get 34 4/10. We look at this problem right here. We don't look back up to the original problem. We look to the problem that we rewrote to see what sign our answer has. They are both positive numbers, so it's a positive 34.4. We always look to the problem that we rewrote. All right. Again, we've got subtraction, so we are going to rewrite that. First number is negative 34 5/10, so we'd write negative 34.5. Change subtraction to addition. Take the opposite of negative 5.42 is a positive 5.42. They have different signs, so that means something's going to cancel out. Okay, so we've got to do some subtraction. So 34.5 is the larger number, so that would go on top. 5 42/100. Notice how I stacked those decimals on top of each other. Oh, and we're subtracting, sorry, not adding. Can't do 0 minus 2, so we borrow from the 5, make it a 4. Turn the 0 into a 10. 10 minus 2 is 8. 4 minus 4 is 0. Can't do 4 minus 5, so we borrow. Look back up to our problem that we rewrote, not our original problem. We've got a negative plus a positive. The negative was larger. A 34 is larger than a 5, so this would be a negative 29 8/100. If you haven't already, start trying to do some of these examples on our own. Okay. Here we've got addition, so there's nothing to rewrite. One's negative, one's positive. Different signs means we subtract to see what cancels out. Again, hopefully you are trying this on your own, so you're just using this video to check your answer at this point. The negative 31 is larger than the positive 7, so our answer would be a negative 24 3/400. All right, that was it for decimals. Fractions. Fractions, just remember that we need a common denominator. That is the main thing that we need to do. Otherwise, we follow those same rules for adding and subtracting that we have been for this whole entire note page so far with those decimals and with those integers. So let's just remember finding a common denominator. If we cannot make the smaller number into the larger number, for example, 3 times something does not equal 4, we would find a multiple that would be the same, or you could multiply those two together. For example, this common denominator is 12. To get the 4 to be a 12, we'd multiply by 3. Whatever we do on the bottom, we do to the top. This will become 6. Oh, sorry, these. My bad. To get the 3 to be a 12, we'd multiply by 4, not 3. We would get 8 twelfths plus 1 and 3 twelfths. Two different ways we can add this up. We can take our whole numbers. We have a 0 here and a 1 here. That would be a 1. And then I can add my fractions. So I've got an 8 twelfths plus a 3 twelfths. When we add fractions, we just add the numerators. 8 plus 3 is 11. Keep the denominator the same. You could also do that by making this fraction improper. You would have 8 twelfths plus 12 times 1 is 12 plus 3 is 15 twelfths. This would get us to 23 twelfths. Then when we simplify that back, it would be 1 and 11 twelfths, because 12 can go into 23 one time. We'd have 11 twelfths left over. Okay. All right, like I said, go ahead, try to start these problems on your own. You should be using this video just to check to make sure we're doing it correctly. Common denominator here is 6 times 2 times 2. 8 times 2 is 16, so this becomes a negative 16, 6, plus a 3 and 5, 6. I'm going to go ahead and make that improper because I think that is the easiest way for me to do it, because then I just have integers to add. I don't even have to think about fractions anymore. So I'm going to change this problem into negative 16, 6 plus 6 times 3 is 18, 19, 20, 21, 22, 23. I have a negative 16, positive 23. So I would be subtracting to see what cancels out. I would get 7, 0, so it'd be 7, 6. 23 is larger than negative 16, so that would be positive 7, 6. 6 can go into 7 one whole time. 6 times 1 is 6, so if we took away 6 of the 7, we'd have 1 left. Okay. Number 2. These are both negative, so I would keep them this way. We could make them improper too. Let's just go ahead and make that common denominator first. 7, 14. Common denominator is 14. So we make this a negative 2 and 2 14ths plus a negative 6 14ths. Like I said, they are both negative, so we just add them together. The negative 2 plus a 0 is a negative 2. A 2 plus a 6 is an 8. 14ths. 8 and 14 can both be divided by 2. This would equal negative 2 and 4 sevenths. You could have also done this by making them improper. Okay, 28 plus 2 is 30. You get negative 36 14ths. We'd reduce that and we'd end up with the same answer. Okay. Number 3 and 4 are subtraction, so make sure first step is always to rewrite them as addition. Again, I'm going to go through these really quickly because I want you to be doing these on your own and just using the video to check. So you should already have work on your paper by the time you're watching this part. Okay. Common denominator is 12, so we'd multiply times 4. 8 times 4 is 32. 12s minus. I'm going to make this improper, or sorry, I'm going to rewrite it so it'd be, well, no, I'll rewrite it next, sorry. Make this improper, so 12, 13, 14, 15, 16, 17, 12s. Then I'm going to rewrite our subtraction as addition of the opposite. This becomes negative 32 over 12 plus opposite of negative 17 12s is positive 17 12s. Negative 32, positive 17, those are different signs, so we would subtract them. 32 minus 17 would get us 15. 32 is larger, so we keep the sign of the larger one, which is negative 15 twelfths. 12 can go into 15 one whole time, and it's negative. And then 15 minus that 12 that we took out to make the 1 would give us 3 twelfths. 3 and 12 can both be divided by 3. So last, final step would be 1/4. Divide 3, divide 3. All right, again, you should be trying these on your own. So pause the video if you haven't done this one yet. Common denominator is 12. We've done a lot of 12s today. 8 times 4 is 32 twelfths. Same as before. Minus 15 twelfths. Then I'm going to change it to addition. Negative 32 twelfths plus, then take the opposite of a 15/12, negative 15/12. From here, we relook at the problem. We are adding two negative numbers, so we just add them together, keep our answer as negative. Negative 32 plus 15 is negative 47/12. 12 can go into 47, and it's going to be a negative. 12 can go into 47 3 times. That would be 36. So if we took away 36 of these, we'd be left with 11. Okay, I know I went pretty quickly through those problems because I really wanted us to try to do them on our own first. And we're just using this video to check and to adjust the answers that we already got. If there's any parts that you need to go back, rewatch, make the speed slower, so I'm talking slower, you may go ahead and do that. Otherwise, that is how we are adding and subtracting fractions and decimals.